Hello GCSE Physics people. This is just a short revision video on the topic of moments. It's not to replace your own revision, it's just to explain anything maybe you're not so sure about. First thing you need to know is what a lever is. And a lever is just something that makes life a bit easier for us. It helps us to do things easier. It means you can provide a very small force and then get a very big force produced at the other end of the lever. Levers always have a pivot, and a pivot is just the point where it turns. So the pivot in a door would be the hinge. The pivot in something that's being suspended is the point where it is being suspended from. Next thing you need to know is what the centre of gravity is. And the centre of gravity is the point that in a calculation you take the weight to act at. If they ask for the definition, you say the centre of gravity of an object is the point where the weight appears to act. If they ask for a definition of the centre of mass, you say it's the point where the mass appears to act. Now at GCSE, most of the things you'll be dealing with will be uniform. And uniform just means it's the same the whole way through. So a meter stick would be a common example. It's the same density the whole way through. The centre of gravity is going to be exactly in its middle. And that holds for absolutely anything that is uniform. One experiment you need to be aware of is how to find the centre of gravity of an irregularly shaped lamina. So a lamina just means something that is flat, and irregularly shaped just means it's not a nice, neat shape, and you can't just measure to find the exact centre using a ruler or whatever. You have to carry out an experiment similar to this to find the centre of gravity. First thing you need to do is to hang your lamina freely from a retort stand, and you'll use a pin or something to do that. And by freely I mean that it will naturally fall where it wants to. If you rotate it 90 degrees, it won't just stay there, it'll fall back to where it naturally wants to sit. Next thing is to hang a plumb line from the same point as you are suspending your lamina from. And a plumb line is just a piece of string with some weights on it. And you're using that because it will always hang completely vertically. Next thing you want to do is to mark the position of that plumb line on the lamina. So if you mark two X's with the centre of the X on where the string is hanging from the plumb line, then you can take it off and join those two X's up with a nice straight line. Then rotate your lamina roughly 90 degrees, do the same thing again, and where those two plumb lines cross, that's where your centre of gravity will be. Then just to check, rotate your lamina again and do the same thing again, and the three lines should cross at the exact same point, so you know for sure you found the centre of gravity. Now, the position of an object's centre of gravity determines how stable it will be and whether it will topple over or not, and that's obviously very important whenever objects are being designed for safety reasons and so the object doesn't fail. You can increase the stability of an object by doing two things. First thing is to lower the centre of gravity, and the second thing is to increase the area of the base. So certain objects would be designed to do this. For example, a wine glass. Whenever it's full of wine, a lot of the mass is obviously up at the top. So that's why it's designed to have a big wide base, and you'll notice the base would be thicker than like the stem or the glass in the bit you drink out of, and that's to distribute the mass a bit more evenly and have some more mass down towards the bottom. Another thing that is designed to be nice and stable is a traffic cone, because obviously it would be very dangerous if one of those toppled over on the road or whatever. So a traffic cone is designed to have a big mass at the bottom, so it's obviously much wider at the bottom to give more material, and then that's going to be slightly heavier than at the top to keep it balanced. And sometimes as well they would be filled with sand at the bottom to put extra mass down at the bottom. And that keeps the centre of gravity nice and low to stop it from toppling over. With people, if you're someone who happens to have a very large bottom half of your body, you will be more stable than someone who just works on their biceps all day and has a very large top half of their body, small bottom half of their body, they won't be very stable. One thing they might ask you to do in the exam is determine whether something will topple or not if it is tilted. So there's things you need to do. First of all, mark the centre of gravity on the object and then draw a line vertically down the way and see whether it passes through the base or not. Now whenever you draw that line vertically down, what you're really doing is drawing the weight and seeing whether that creates a moment about that pivot, which would be the corner where it's touching the surface. So you're seeing whether that moment is going to make that turn over onto its side, or whether it's going to turn back onto its base again. So basically you're seeing whether it's anti-clockwise or clockwise and seeing what effect that's going to have on the object. When a force is applied to a lever, it's going to have a turning effect. So it's going to make it turn either clockwise or anti-clockwise. And the name of that turning effect is the moment of the force. There's an equation you can use if you're asked to calculate the moment of a force. If you're asked just to state the equation, make sure you write it out in words, and you would write it as moment equals force times perpendicular distance from pivot. And having the words perpendicular and from pivot there is very, very important. Now if you're just using the equation, then it's fine just to write it as m equals f times d. And you need to make sure you're very careful with units. Force is measured in newtons, and you write that with a capital N. If distance is in meters, then that means your moment is going to be in Newton meters. However, if distance is in centimeters, that means your moment will come out in Newton centimeters. And make sure you pay attention to what unit they are looking for you to give your answer in. Look at the answer space on your paper and see what it is, and make sure you have your distance in the right units for that. Now it won't always be as straightforward as they give you the force and the distance and ask you to calculate the moment. Sometimes you'll have to rearrange the formula to either calculate force or distance. So you can just use straightforward algebra to rearrange the equations like that and then use them from there. Or you can use an equation triangle to rearrange. And to use the equation triangle, you put the version of the equation you know into your equation triangle and then cover the letter you're looking to find. So if you're looking to find moment, cover the m and you're left with f times d. If you're looking to find force, cover f and then you're left with moment divided by distance. And if you're looking to find distance, cover d in the triangle and then you're left with m over f. Anytime you're doing any sort of calculations, you need to make sure you set all your working out properly. And to do that, you need to make sure you write the formula out, then substitute in the numbers, find your answer, and then put units on them. And that's 1 mark for each of those things. The principle of moments is another one of those things you have to learn off by heart. If they ask you to state it, make sure you write it out word for word. For an object to be in equilibrium, the sum of the clockwise moments about a point must be equal to the sum of the anti-clockwise moments about that point. And I've underlined the bits here that are important for you to put in if you're looking to get full marks when you're asked to state that. In equilibrium is just a fancier way of saying that the object is balanced. I'm going to look here at how you would set your workout for a few different scenarios where you're applying the principle of moments to calculations. So first of all, a nice straightforward one, just with one force either side of the pivot. You would look and see what's creating the anti-clockwise moment, what's making this lever turn anti-clockwise, and in this case it's the force that I've labelled F1. So you have a moment for it, force times distance, and then you'll have a moment for the F2, which is making the object turn clockwise. So in this situation where the lever is balanced, you would put those two moments equal to each other and then substitute in your values and then solve for whatever the unknown was. It could be one of the forces or it could be one of the distances. The next situation is one where you maybe have two forces which are both creating the same type of moment. So in this one I've got F1 and F2, which are both making the object turn anti-clockwise, and then I have F3, which is making the lever turn clockwise. So you need to calculate the moment for each of those anti-clockwise forces separately, add them together, and then put them equal to the moment created by F3, which is the clockwise one. This next situation is one that catches a lot of people out. So say you have a lever and it's supported at one end, and then it's held up by a force acting up the way at the other end. They may ask you to calculate the weight of this beam, and that's where you put your knowledge about the centre of gravity to good use, because you need to remember that the weight acts at the lever's centre of gravity. So if this is a metre stick, it's going to be acting at the 50 centimetre mark. And then use the information they've given you about where the beam is pivoted to work out that distance to the pivot. Then you need to think about what way each of the forces is making the lever turn. So because the force F1 is acting up the way, if we follow it round, it's actually making the lever turn anti-clockwise, and then the weight is making the lever turn clockwise. From there then it's just substituting in your values as before, and then solving for whatever value they may be asking you to calculate. Okay, remember that's just the basic facts. What you need to do now is to go and practice lots of questions and then ask your teacher for help on anything that you are finding difficult or anything that you're stuck on. Have fun!